simplify this one using Boolean algebra. Let's look at the first two things. Can we take anything common and simplify this one? Here we have x bar y, x bar y. So we can take that one common. We do that, this is going to be x bar y and then z bar plus z. And we have a property in Boolean algebra that whenever we have a bar and the complement of, like whenever we have something and the complement of it in plus, it's going to be just 1, because let's say you put 1 here, this is going to be 0. If you put 0 here, this is going to be 1. Then there's always going to be a 1. And when this is like an OR gate. In OR gate, if you have just 1, it's going to make the whole thing 1. So this is going to be 1. So we are going to have just x bar y, because x bar y times 1 is going to be just x bar y. So we can just write it as x bar y. Now we just dealt with these two. Now let's look at these two here. Can I take anything common here? Here we have x bar, xy bar, xy bar. So we can take that one common. If I take xy bar common, this is going to be z bar plus z. Again, exact same thing. Like if you have something and a complement of it, if both of them are added, it's going to be 1 always, because this act like a OR gate. So in OR gate we just have to have just 1 in order to make the whole thing 1. So this is going to be 1 as well. So this is going to become xy bar times 1. That's going to be xy bar. And last we have xyz. Okay, so for these two I cannot take anything common. For these two I can take x common, but that's not going to do anything, because we have y bar plus yz. We cannot simplify anything, so we can just leave it as it is, and this is our final expression. Now let's actually try to design this circuit. So first we have x and y here, x bar and y, and this is in AND gate, because this is like multiplication is like AND gate in gates, logic gates. So here we can, if we input x bar here and then y here, the output is here going to be x bar y here. Okay, and this one is connected to an OR gate because we are adding these things. And then here we are going to have AND gate, and in this AND gate, if we put input x and y bar, the output is going to be x y bar. So we are connecting both of them to an OR gate, and we have one more input to the OR gate, that is this AND gate here. You can actually put 3 input AND gate as well, like x y z, but if you put 2 input AND gate, that's cost effective. Like we can also make this one as x 1 input and then add another 2 input OR gate, 2 input AND gate, y z right here. And if you do that, this is going to be cost effective. So if this is going through the AND gate, this is going to be yz here, and then yz x, that's going to give us yzx. So that's the expression we have right now. That's the expression we derived. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.